Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. A very warm welcome to Mayank. How are you? Welcome to the session. All the candidates who are joining me, just quickly tell me whether my audio and visual quality is okay so that we can proceed. All the candidates who are joining me, just quickly tell me whether my audio and visual quality is okay so that we can proceed. So friends, today we are going to have the second session in this series of previous year question papers analysis for electrical machines part 2. We are discussing the important questions asked when the IIT Bombay conducted the gate examination. I hope it is clear to all of you. Now introducing Gradeup Super, which is going to give you unlimited access to all these structured live courses and mock tests with just one subscription for your exam category. Today is the last date, 18th of August. Today is the last date for the super launch offer. In the super launch offer, you will be getting 2 times validity and extra 20% discount. What is the meaning of this statement? The meaning is if you are choosing the 12-month subscription, instead of 12 months, you will be getting 24 months subscription at the cost of 12 months minus 20% discount. I hope you are getting this point. And also you are having chance to win prizes worth rupees 25 lakhs, that is laptops, smartphones and smart bands. So if you are interested, you can go for it. Today is the last date. If you are having any doubt regarding this Gradeup Super subscription, you can ask me or you can contact our backend team. They are going to help in all possible way. Good evening, Shiva Shankar, Prezi, Gold and Purna Kola. Everybody, how are you? Welcome to the session. Now friends, before I start the session, the homework question for which I have 3 candidates name. Number 1 is Cherukuri, Tirumalasi, Annapurna Kola and Teja. I wish all these 3 candidates to stay connected to Gradeup platform. We are going to do wonders next year in the examination and I want you people to get your names in the GATE merit list also, GATE or whatever exam you are preparing for. The solution for the previous homework question, the real and reactive power or the load shared is 7.466 kilowatts and all 3 of them have given the right answer, 6.787 kVAR. So if you are not aware, you can watch my previous session, you will be getting the idea. Now, some of you may be joining me for the first time. My name is Ashutosh Saxena. You can see my brief profile on your screen. And if you want not to leave any of my classes, then you have to follow the LSS method. What is LSS method? All the candidates who are watching my session right now, like, subscribe, and share this session with your friends and colleagues so that you do not miss any of my classes. Now let us start with the first question. Just see the first question. Tell me what is the answer you are getting. Just quickly tell me what is the answer you are getting. Then I will make you understand what is the correct answer. Just tell me quickly. All the candidates who are watching the session, just quickly like the session. Quickly like the session and tell me the answer to the question on your screen. Good evening, Nishant. How are you? Welcome to the session. Good evening. Good evening. How are you? Welcome to the session. Tell me what is the answer you are getting. The first question on your screen. Any answers? All the candidates who are live, just quickly like the session. Good day, Rajan Mishra. How are you? Welcome to the session. Now listen carefully. Let us try to understand the problem first. What the problem is saying? The problem is saying a cumulatively compound long shunt motor. Now you forget about the long shunt motor. First you understand what is cumulatively compound machine. Cumulatively compound machines, it is having both shunt and series field winding. Both the shunt and series field winding it is having. Okay, Nishit, please wait. Some people are saying B, some people are saying C. Now listen, Baba, listen. listen. Hey, Baba, listen. Suppose this is your pole. Let us understand what is cumulatively compound machine. Then we will understand the question. You are having both the shunt and series field. Suppose it is the shunt field and it is the series field. It is the series field. Now when it is cumulatively compound machine, it means what? It means the flux because of the shunt field and the series field is going to be in the same direction. Suppose this is the flux because of the shunt field and this is the flux because of the series field. So both are going to be added together. That is why it is called as cumulatively compound machine. So what is the resultant flux you are getting? It is going to be shunt field flux plus series field flux. This is how we are defining a cumulatively compound machine. Tell me yes or no, are you getting this idea? Everybody, are you getting this idea or not? What is cumulatively compound machine? We are not interested long shunt, short shunt. We are just interested in the cumulatively compound nature of the machine. Now he is saying it is driving a load at the rated torque and the rated speed if the series field is shunted by a resistance equal to the resistance of the field winding. What is the meaning of this statement? Suppose this is the series field winding. So what you are doing, you are shunting this series field with a resistance which is equivalent to this series field winding. Is it clear? Keeping the torque constant. So what is going to happen if you are applying shunt? So what is happening? Some current is going to flow through this short. You are actually shorting with some, you can say with some resistance you are shorting the series field instead of direct shorting or the solid shorting. So what is happening? Some part of this series field current is going to be bypassed with this resistance. Yes or no? It means the current through the series field is going to be reduced. Are you able to follow this or not? Current through the series field is going to be reduced. If the current through the series field is going to be reduced because some current has been bypassed, there is some alternate path is available. So what is happening? The series field flux being directly proportional to the series field current, series field winding current. If the series field current is reducing, series field flux is reducing. If the series field flux is reducing, it means the total resultant flux is going to reduce. The total resultant flux is going to reduce. How you are going to define the torque? How you are going to define the torque? Torque you can write as KZIA, where K is the machine constant. It is given as PZ upon 2 pi A. So you can write torque is going to be directly proportional to flux and the armature current. It is given in the problem. It is given in the problem keeping the torque constant. Please do not argue. Do not write comments when I am speaking. Try to understand the concept. It is more important. Okay. If you know the answer, well. If you don't know the answer, that is also okay. Because we are here for learning. We are not here to show off our skills. Now listen carefully. So what I am saying, the torque he is saying is same. Torque is constant. Now, Baba, if torque is constant, resultant flux has reduced, so the armature current is going to be increased. So what is the correct answer? Are you getting this idea? Are you getting this idea? Yes. So what is the correct answer? Armature current is going to increase. Armature current is going to increase. Yes, why not, Soumya? I think it is the best course available you can have. If you go for a 12-month subscription, you will be paying 12 months cost less than 20%. Today is the last date. Today is the last date, and you will be getting 2 years subscription. Is it clear? Kumawat Ashok, if you have any other objective rather than understanding the concept, please you can leave the session. Kumawat Ashok, I'm repeating my statement. Clear? Now let us go to the next question. See the next question. Now this question I will not ask for the explanation from your side. I will try to make you understand this particular question. This question is talking about a 4-pole lap wound DC generator. 4-pole lap wound DC generator. What does it mean? Let us try to show the lap wound machine. Let us try to show the lap wound machine. Suppose these are the brushes. These are the brushes because it is a 4-pole machine. So the number of parallel paths are going to be 4. Suppose we are showing the number of parallel paths like this. These are the parallel paths available for a lap wound machine. Suppose this is brush B1, this is B2, this is B3, and this is B4. And this is how the connections are being made. These are the positive brushes. Suppose these are the positive brushes. And suppose these are the negative brushes. These are the negative brushes. So what is happening? If these are the positive brushes and these are the negative brushes, so definitely the direction of currents are going to be like this. IC, IC, yes or no? IC, IC. Are you able to follow this or not? What is the total current coming out of this brush B1? It is going to be 2IC. B3, it is going to be 2IC. And it is going to be 4IC total current coming out of this terminal. If you see total current entering brush B4 and B2 is going to be 2IC and 2IC. What is the total current entering? It is going to be 4IC. So if this is your output terminal and this is your EMF which you are getting across the terminals of the generator, listen carefully, listen carefully. Now he is saying has developed a power of P. How you are going to define the developed power? The developed power you are going to define by the EMF induced and the total current. Total current is 4IC. So this is power P you are defining, say equation number 1. Are you able to follow this circuit? Tell me yes or no. Because it is a 4-pole lap wound machine, so there are 4 parallel paths, 4 brushes we are using, 2 brushes for positive polarity, 2 brushes for negative polarity, and this is how we are going to make the connections in the machine. Are you able to understand the circuit connections or not? Now see what he's saying. He's saying 2 adjacent brushes of the machine are removed as they are worn out. So 2 brushes you are going to remove. What are the 2 brushes you are going to remove? Just see here. Suppose these are the 2 brushes you are going to remove. If you are going to remove 2 brushes, it means this path is not going to be available and this path is not going to be available. So what is going to happen with the currents? The currents in the individual coil. The currents in the individual coil. The current in this coil is going to be 0, in this coil it is going to be 0, and in this coil it is going to be 0. It means here also it is going to be 0, here also it is going to be 0, here it is going to be IC and only IC current is going to flow here. So what you are getting, instead of 4IC, now you are getting only IC current. only IC current. So what is the power you are getting? P dash power that you are getting is going to be, because EMF is not going to change, because all the parallel paths. Listen, Baba, listen. Praise ye God, listen. All the parallel paths, they are going to have the same voltage across them because they are connected in parallel. So even if three parallel paths are not available, one parallel path is available, but the EMF induced is going to be same. So EMF we are taking as E. What is the current? Current is now only IC. So it is IC. So it is how much? It is going to be P divided by 4. Are you able to follow this? So what is the EMF you are getting if the two brushes are worn out? It is going to be same E. And what is the power P? It is going to be P by 4. What is the correct answer? No answer is matching. So what we are going to do? We are going to correct the option. If no option matches, we correct the option. Is it clear? Tell me yes or no. Are you able to follow this? Are you able to follow this? Are you able to follow this? Is it clear? Is it clear, Baba? Yes. Now I'm giving you one more similar question. You try to solve it. 6-pole lap wound DC generator. Okay. Again, I am saying two adjacent brushes are removed. Again, you have to find what is E dash and what is P dash. What is E dash and what is P dash? And that is what I am discussing, Nishant. That is what I am discussing. Don't worry. I am discussing all the cases. Don't worry. What is going to be EMF induced and the power for a 6-pole lap wound DC generator if two adjacent brushes are removed? Now listen carefully. There is a logic. What is the logic? The logic is how many number of parallel paths are opened if you are removing the two adjacent brushes? 2 plus 1. This is 1, 2 and 3. It means you can apply a logic. Number of parallel paths opened is equal to number of brushes removed plus 1. Yes, Praise God, you are right. So what is happening? If it is a 6-pole lap wound machine, so it is going to be 6 parallel paths available. There is going to be 6 parallel paths available. Yes or no? 6 parallel paths are available. This is the situation. There is a 6-pole lap wound machine, equivalent circuit, you can understand. Now suppose one winding current is, one parallel path current is IC. What is the total current? Total current is going to be 6 IC. Suppose EMF is E. So what is the power? Power is going to be E multiplied by 6 IC. Now suppose what you are doing, suppose two adjacent brushes you are removing. So how many parallel paths are going to be opened? How many parallel paths are going to be opened? 1, 2 and 3. If three parallel paths are now opened, so now what is going to be the current? The current is going to be, instead of 6 IC, now it is going to be 3 IC, but the EMF is going to remain same. So what is power P dash? It is going to be E 3 IC, or you can say P by 2. So for a 6-pole lap wound machine, the EMF E dash is going to be same as E and the power is going to be P by 2. Are you able to follow this or not? Tell me yes or no. Are you able to follow this shortcut? Annapurna Kola, is it P by 2, not P by 3? Rayudu, are you getting this? Tell me yes or no in the comment section. Are you able to follow this? Are you able to follow this? Are you able to follow this? Now suppose what happens, there is one candidate, he is asking what happens if there is any other case. If there is any other case. If you remove one brush, no problem, you can apply the same logic. Two parallel paths are going to be opened. But if you are opening the opposite brushes instead of adjacent brushes, you are opening the opposite brushes. What does it mean? For example, suppose it is a 4-pole machine. How many number of brushes? 4. Suppose you are removing the opposite brushes B1 and B3. What is going to happen? It means the positive terminal is not available. So if you are removing the opposite brushes, what is going to happen? Power is going to be 0. Power is going to be 0. Are you able to follow this? Are you able to follow this? Tell me yes or no. Now let us go to the next question. Just see the next question. Tell me what is the answer you are getting. Yes, praise you God, you are right. Everyone tell me just quickly about this question. What is the answer you are getting? And all the candidates who are watching this session live, do not forget to like this session. Do not forget to like this session. Is it clear, Baba? What is the answer for this question? Tell me quickly. Tell me quickly what is the answer to this question. He is saying a DC shunt motor is running at 1200 RPM when excited with 220 volt DC. Nishan is asking, sir, how power will be 0? Because no terminal is available, Baba. Na? Suppose there are 4 brushes. 4 brushes. These 2 opposite brushes for the positive terminal. These 2 negative brushes for the negative terminal. Now 2 opposite sides brushes, if you remove, there is no positive terminal. Are you able to follow? So you will not be able to supply any power. So power supplied is 0. Yes. Some of the candidates, Nishit Omkar is saying D option. Now let us understand what is the correct option. So he is saying for 220 volt DC, the speed is 1200 RPM for the DC shunt motor. He is saying neglecting the losses. All the losses he are neglecting, and the saturation also. The speed of the motor when connected to 175 volt DC supply. It means he is asking about the 175 volt DC supply. What is going to be the speed? Is it clear, Baba? Yes or no? Now see what is happening. If it is a DC shunt motor, it is something like this. If it is a DC shunt motor, it is going to be something like this. Just quickly see the circuit diagram so that you can visualize what is actually happening. This is a DC shunt motor. This is the shunt field. This is the shunt field, and because it is a motor, so voltage, terminal voltage is nothing but the supply voltage. Are you able to follow this? Now this supply voltage is going to provide some line current, which is going to provide the armature current and the shunt field current. Now the field flux is going to be directly proportional to the shunt field current, which is directly proportional, or you can say which is equal to the terminal voltage divided by the shunt field resistance. This is RSH, this is RA, but RA he is saying as 0 because the losses he is saying are 0. Losses 0 means even the copper losses in the armature circuit are going to be 0. Armature reaction 0. Are you able to follow this? So now you can say that the flux is going to be, field flux is going to be directly proportional to the terminal voltage. Say this is equation number 1. Are you able to follow this? Are you able to follow this or not? Tell me yes or no. Yes or no? Now when this armature resistance is 0, it means the terminal voltage V is going to be same as the back EMF. Mahesh Nandanur is asking for 6 pole opposite is deleted. It depends upon the situation. You just imagine there are 6 parallel paths available. If he is if he is removing the opposite brushes in the sense that you can still supply the power, then you have to find the respective current. EMF is going to be same. But suppose he is removing such number of opposite brushes so that you cannot supply the power, so you can find accordingly. For a 4-pole machine, 4 brushes, 4 parallel paths, opposite brushes removed, not allowed. Are you able to follow this? Now you can understand, it means the back EMF is going to be same as the supply voltage, or you can say EV is going to be directly proportional to V. Equation number 2. When you will start up 3.0? See, 3.0, I don't know when I'm going to start. Definitely it will come very soon, but I am already taking lot of free classes on the Gradeup app. So if you are interested in my classes, I'm taking power system, machines, and a lot of other subject, engineering ethics. So if you are interested, you can switch to the Gradeup app and you can enjoy a lot of sessions. Mahesh, I hope I have answered your query. Now you can say that your back EMF is going to be directly proportional to flux and the speed. So you can say speed is going to be directly proportional to back EMF upon flux. Now suppose you are reducing the voltage from 220 volts, you are going for 175 volts. So voltage reduce means flux reduce. Voltage reduce means back EMF reduce. It means both back EMF and flux, they are going to reduce. It means the speed is going to remain almost constant. Remain almost constant. Are you able to follow? What is the correct answer? D. See the next question. It's okay, Mahesh. All the candidates who are joining the session, do not forget to like it, share it with your friends and colleagues. Let more and more candidates join the session, okay? Then only we'll be able to bring more and more such sessions for you. Is it clear? Now this question is really difficult one. This question is really difficult one and very important. One of the previous year GATE examination question. This is really difficult one, and I will tell you how to approach this problem. Are you ready? Tell me yes or no. Are you ready? Are you ready? Yes, yes, yes. Annapurna Kola is saying, sir, repeat. What do you want me to repeat? I think that is easy question. You can watch it again and you can understand. Shall we start the discussion? Now see what he's saying. He's saying a separately excited DC shunt motor is driving a fan load whose torque is proportional to the square of the speed. It means for the fan load, the load torque is going to be directly proportional to the square of the speed, or you can say the load torque is going to be equal to K omega square. Call it K1. Ready? Okay. Now he's saying when 100 volts are applied to the motor, the current taken by the motor is 8 ampere with the speed being 500 rpm. It means what? Now case 1, 100 volts, current is 8 ampere, that is the current taken by the motor, and the speed is 500 rpm. 500 rpm. He is asking at what applied voltage? At what applied voltage? It means he is asking the terminal voltage. The speed reaches the 750 rpm. It means he is asking about the second case, voltage for which the speed, if it is N1, it is N2, reaches 750 rpm. And then what is the current drawn by the armature? What is the current drawn by the armature? Assume the armature circuit resistance to be 1 ohm. Assume the armature circuit resistance to be 1 ohm. Neglect the brush and the mechanical losses. Neglect the brush and the mechanical losses. Is it clear to everyone? Are you able to follow? Yes. Now let us, in this type of question, let us first try to understand what he is trying to ask. What he is trying to ask. Are you able to follow this? He is saying that a fan load is connected to a separately excited DC motor. Okay? A fan load is connected to a separately excited DC motor. What is the meaning of this statement? The meaning of this statement is there is some torque which we are calling as electromagnetic torque, and that is given as K phi IA. Do you remember this formula? This is the electromagnetic torque being generated by the shunt motor. And this motor shaft is coupled to a fan load. That fan load is having this load torque characteristic. So load torque you are having K1 omega square. Now he is saying the mechanical losses you are going to neglect. What is the importance of this statement? The importance of this statement is if you can neglect the mechanical losses, then you can write the electromagnetic torque is going to be available at the load torque as there is no mechanical losses involved. Are you able to follow this? The first concept, the first equation that we are going to use in this question. Are you able to follow this? Tell me yes or no. What is the meaning of mechanical losses? You understand the power stages in DC machine? Whatever torque you are generating, that is electromagnetic torque. But all of that torque is not available at the load torque. Some of that torque is going to be lost because of the mechanical losses, friction and windage losses. Are you able to follow this? Are you able to follow this? Yes or no? Are you able to follow this, Baba? Yes. Now see, if you see the first case, from the first case, can you find the back EMF? Can you find the back EMF? Terminal voltage you know, current drawn you know, armature resistance you know. Yes. So can you find the back EMF for case 1? Yes or no? Case 1. What is the back EMF you can write? Back EMF is going to be V minus IA RA. What is V? V is 100. What is IA? 8. What is RA? 1. So it is going to be 92 volts. Now what is the advantage of getting the back EMF? Now see the advantage of getting back EMF. What is the relation for back EMF? Back EMF is given as K phi omega. Are you able to follow this? This is K phi omega. Suppose this constant we are saying as this constant K phi we are saying as K dash. So this K phi is going to be K dash. You know the back EMF, you know the speed. You know the speed also. So can you tell me what is the value of K dash? Can you tell me what is the value of K dash? Yes or no? Very easily you can tell me. What is the value of K dash? What is the value of K dash? K dash is going to be the back EMF EB1 upon speed. What is the speed? 2 pi n upon 60. You are going to write omega like this. What is omega? Omega is 2 pi n. N is revolutions per second, but you want to write in terms of RPM. In terms of RPM, it is going to be 2 pi n upon 60, where n is in RPM. Just put all the values. What is the speed? Speed is given as 500 RPM. Back EMF you have got as 92 volts. Put out the values and tell me what is the value of K1 dash you are getting. Tell me what is the value of K1 dash you are getting. Because if you are getting the K1 dash value, what is the beauty of this? The beauty of this, Baba, is if you know K dash, it means what? For any speed, you can calculate the back EMF directly. Are you able to follow this? Crazy gold, perfect. 1.757, 1.757 is K dash. Perfect. All other candidates, you please also confirm this value. Are you able to follow this? Yes or no? Are you able to follow this? Yes. Now see, let us try to find what is the torque in this case. Can you tell me what is the torque in this case, electromagnetic torque in this case? Because in the first case also that fan load was connected. So what I will do, I will use this K phi is equal to K dash to find the torque, and that torque I am going to relate with the fan load torque. So what I will get? I will get the value of this parameter K1. Are you able to follow this? Tell me yes or no. How many candidates are you able to follow this? If you can follow this, you can handle one of the most difficult problem in DC machines in your gate examination. Are you able to follow this? Crazy Gold is way steps ahead. What I am saying, I am trying to find the torque for the first case. Which torque? Electromagnetic torque. It is going to be K phi IA. Suppose it is IA1. What is K phi? It is K dash. What is IA1? 8 ampere. Just multiply this 1.757 with 8 and you will be getting the electromagnetic torque. Are you able to follow this? How much electromagnetic torque you are getting? Just calculate. How much electromagnetic torque you are getting? Just calculate. It is 14.056. It is 14.056 Newton meter. But this is connected to the fan load. This is connected to the fan load. So electromagnetic torque is going to be equal to fan load, and fan load is going to be K1 omega square, Baba. What is omega? Do you know for case 1? Yes, you know what is omega for case 1. Omega is 2 pi n1 upon 60. 2 pi n1 upon 60. Omega is going to be 2 pi n1 upon 60. What is electromagnetic torque? This value. Can you tell me what is the value of K1? Who is going to tell me the value of K1? Baba, who is going to tell me the value of K1? Who is going to tell me the value of K1? K1 you must be getting 5.13 10 to the power minus 3. Something like that. Please confirm this value. 5.13 10 to the power minus 3. Are you getting this value? Are you getting this value? Just tell me. If you are getting this value, then this question is over. Last statement and this question is over. Are you getting this much K1? Prezi, Nishant, Anupam, Teja, just tell me. Are you getting this value of K1? Just put the value of electromagnetic torque 14.05. Omega square is 2 pi n1 upon 60. Use your fastest calculator. You are getting great. Now listen. Listen. The moment you get K1, what is the beauty of K1? The beauty of K1 Baba is, what is the load torque? What is the load torque? Load torque you are saying it is K1 omega square. It means if you know the speed, for any speed, if you know K1, you can find the load torque. Now listen carefully. What is the speed for the second case? 750 RPM. In terms of RPM, you have to put 2 pi n2 upon 60. In terms of n2, you have to put this value. Are you getting this? The moment you put this value, K1 is known to you. Can you find the load torque? Yes, you can find the load torque. If you can find the load torque, you equate it to the electromagnetic torque, and that is given as K dash IA2. It means if you get the load torque, it is equal to electromagnetic torque because mechanical losses are 0. K dash you know. Can you find the current? Are Baba, can you find the current? Do you understand what is the logic? Are you able to follow this? Sai Kumar Palnati, thank you so much. Are you able to follow this or not? Not getting? Getting this thing or not? Are you getting this thing or not? If you know the value of K1, you can find the load torque for the connected fan load for any speed. What is the required speed? 750 RPM. You will put 2 pi n2 upon 60. N2 speed is 750 RPM. You know the value of K1. Load torque you can calculate. The moment you calculate the load torque, because the mechanical losses are ignored, it is going to be equal to electromagnetic torque. Electromagnetic torque is given as K phi IA2. K phi you are saying as K dash. Do you know the value of K1? Do you know the value of K dash? Yes. Do you know the value of load torque? Yes. Can you find the value of IA2? Yes. Calculate what is the value of IA2. Just quickly calculate what is the value of IA2, Baba. Jaldi se batao. It is going to be approximately 18 amperes. Approximately 18 amperes you must be getting. 18 amperes you must be getting approximately. And the moment you get 18 ampere, the story is over. Because what he is asking? He is asking the terminal voltage. How you are going to find the terminal voltage? Terminal voltage is going to be EB2 minus IA2 RA. RA is 1 ohm, IA2 is 18 ampere. Do you know what is EB2? Yes, very easy because you know what is K1. Sorry, K dash. What is EB2, Baba? K phi omega. What is omega? Omega is omega 2. That is 2 pi n2 upon 60. What is K phi? K phi is K dash value you know. So you know what is EB2. Just put the value of EB2. What is EB2 you are getting? 138 volts. You must be getting 138 volts. Just confirm this value. It is not very tough question. That is what I am saying. If you can understand the logic or the common sense, no electrical engineering is required. What is the purpose of motor? To supply the load. So at all the time, the electromagnetic torque is going to supply the load torque. Mechanical losses ignored, load torque is equal to always electromagnetic torque. Now rest is mathematics. Rest is mathematics, nothing more, nothing less. Are you able to follow this? Just put these values and tell me what is the answer you are getting for this voltage. Tell me what is the answer you are getting for this voltage. Crazy Gold is getting 119.44. I think it is not the correct answer. The correct answer is 156. Just confirm this value. Just confirm this value. Okay. Try to solve it and get the correct answer. I hope you will be getting. Is it clear to everyone? Is it clear to everyone? Now I will be giving you some questions as part of your homework. Just take this question as part of your homework and answer. All the candidates who are watching me live and all the candidates who are going to watch me recorded, give the answers of these homework questions in the comments below this video, and I will be taking your names and giving you the solutions in the next class, that is tomorrow 10 p.m. in the night. Again, I am going to come to you with some more interesting questions. This is homework question 2. It's okay. I'm not sure. Just confirm the value. Okay, I think Crazy Gold, her answer is right. It should be 138 minus 18. 138 minus 18. Just wait. I think this is going to be 18 amperes. This is 138. So it is going to be 138 minus 18. So it is going to be 120 volts. Okay, so this is the correct answer. Crazy, you are right. Is it clear? So these are the homework questions. You can take the screenshot. Homework question 1. This is homework question 2. These questions we are going to discuss. And homework question 3. These are the questions we are going to discuss in the starting of the next class. And I will be taking the names of those candidates who are going to write the correct answer in the comment section. Now, before we stop, again, very important information for all of you, introducing Gradeup Super, unlimited access to all the structured live courses and mock tests with just one subscription for your exam category. Today is the last date, 18th of August, for this super launch offer. You will be having 2 times validity and extra 20% discount if you avail this offer and you go for this subscription today itself. Today is the last day. And what is the idea? The idea is if you are going for 12 months subscription, you will be getting 2 times validity. It means you will be getting the 24 months validity in the cost of 12 months minus this 20% discount. All this you are going to get under the super launch offer for which today is the last date. You are also getting a chance to win prizes worth rupees 25 lakhs, some laptops, smartphones, and smart bands. So friends, thank you so much for joining me in this session. I hope you must have got some value addition. Tomorrow I will be having 10 p.m. Do not forget to attend my class. Thank you, thank you, thank you. 10 p.m. in the evening, or better call it late night, I will be coming to you only on Gradeup Gate YouTube channel. So thank you so much for joining me in this session. Prep smart, score better, go Gradeup. Thank you so much.